We are here with Kevin from Radformation. We're so happy he's the first one to belly up to the bar and have a little run at it. Nice to meet you, Kevin.
Yeah, thanks for having me, Ben.
Do you mind giving maybe just a brief a background on you yourself, and then also the company you work for and how that company came into the AutoSeg business?
Yeah, so physicist by background. So I went to school at Vanderbilt. I did their DMP program. So that was kind of my first foray into clinical medical physics and anatomy, I guess. From there, I went to Memorial Sloan Kettering. So I was on the treatment planning team there. So probably most of my anatomy clinical experience comes from that time. So I was in the treatment planning group, so we were responsible for doing a lot of the OAR segmentations. So yeah, definitely would have loved to have a tool, an auto segmentation tool in the clinic when I was working there, because it did take up a good amount of time. And yeah.
Jumped in to the exciting world of industry.
Yeah, exactly. Yeah.
Where if you develop something, a lot of people can benefit from it rather than just your single site. So who do you work for, and then what's the history? Obviously, it's Radformation. What's the history of Radformation coming into the AI business?
Yeah. So Radformation got its start trying to automate a lot of those processes. So our co-founders were all physicists working in the clinic. They had scripting background, so they had some programming experience and really wanted to bring those tools that they had built in-house for themselves and bring it to the community at large. My background, I did some work with scripting within Eclipse and with the API there, and at Memorial was doing a lot of the constraint checks and trying to automate that process, and realized it definitely had a market at other locations. So yeah, Radformation really started with that clear check, and then EasyFluence was our other early product. And ClearCheck had a module to confirm contours, so to confirm volume and laterality and simple checks. But ultimately, I think with the scripting platform that we had built, it only made sense to get into the AI piece as well, because it kind of paired well with the trying to improve consistency and efficiency for planners.
Time did Radformation have the skill set to actually start programming an AI, or have you partnered with people, or did you go out and find people?
So yeah, we found a great data scientist, Chung Liu from Henry Ford, and he's the one that really built out our models. He had experience publishing really great results, I believe, on the prostate. And when we pulled him in, it was really a matter of just trying to find the data and building out the models from there.
Cool. I think we're actually going to see, before we jump into this analysis versus the population of physicians, you're going to give us a quick tour of what it would have looked like to create these. We won't do it yet, but just as general, I think a lot of people would be interested in, obviously AutoSeg kind of fits into the workflow when you don't see it at all in the workflow, when it's headless, so to speak. So does Radformation, first of all, it probably works with every product, not just with Eclipse via the API, right?
Right. So we have we initially built it as a tool that you could run from the Eclipse API, but what I'll show now is the DICOM standalone version, which can work with any workflow. So usually we recommend just having it set up to be pointed at the directory you would export from your simulator, and then anyone really can run it at that point, just on any image series.
Okay, perfect. Yeah, I'll let you show that in a minute, but I'm actually going to get I'm going to prime the pump here with I think what is really interesting, and where I think some of these consensus, not only the C3RO consensus studies, but there are other ones that are starting to go on. And I really hope there's really good outputs that the AI vendors can use, either for validation or just for studying, knowing how much and where physicians differ in their opinions is probably critical for you. But I want to ask you this question. All right. You have a potential customer, maybe even an existing customer. So you're either trying to sell them or you're trying to get them commissioned. How does that go? Like, what are the range of interactions you have when people, when you're trying to prove, let's say, your accuracy? I'm sure it's fast. I'm sure it's automated. Let's just assume that. What types of discussions do you have when people say, do they say, show us it works, or do they say, give it to us for 3 months and we want to do our own? What does that look like?
Yeah, I mean, we definitely recommend the trial. I mean, you can show a demo case that's obviously any vendor is going to pick the case where everything works out perfectly. But if you really want to try it on what your department's doing with certain setups or your particular CT scanner, maybe it's an older one, maybe it's a newer one that has better resolution. Really, the only way to do it is to test it on those scans and actually implement it in the workflow. So yeah, if it's added to that workflow, is it going to save you time? Because that's probably the most important thing users are looking at. Because you can do it yourself and know you're doing it right, or use an automated tool. So we have a way for users to submit anonymized data. So we can, if they don't want to jump all in and get a trial, they can send us as many scans as they want, and we'll give them some results just to see maybe how it compares initially, and then if they're happy with that, they can step into a trial for a month and see how it works in their workflow.
Are you kind of hands off when it comes to them making the decision of the accuracy of it, or like in particular,
Yeah,
the software, your software model, I mean, I'm sure it'll be continually improving, but your software model for any given image set will produce the same structure set.
yep,
In the real world, you may be selling to a site that's got 5 or 10 physicians, and if they all contour a structure set, they might differ. So these teams of physicians, do you know kind of what's the lay of the land in terms of how they judge? Are they doing quantitative analysis with gold standards they have? Are they doing qualitative analysis? What do you see going on out there?
yeah. We have some sites at this point. I mean, now that we're a little more established, there's a lot of research going on. We know, so we're providing the data sets back, and I know there's a few sites that are doing more of a quantitative approach, but then another one, particularly with our head and neck lymph node volumes, where it's more of a score of 1 to 5 and judging it based qualitatively. So there's certainly a range, and that it kind of goes into how we created the models. It was kind of a mix of trying to get a good dice score and kind of those quantitative values initially, but also looking qualitatively. Would this be useful if I was using it in a treatment plan? And I think most of the feedback we get seems to be following more. Are you following the guidelines that we would expect rather than a dice score that they're aiming for? It seems to be more, are we following the same protocol standard for that contour, which again is kind of how we look at things before we release them clinically or commercially.
Yeah, do you find that I'm assuming you go in and you're having to compete with other vendors. Do do they ever come back with constructive criticism or criticisms at all about, well, we really liked these structures, not so much these? Like, do you get that good input from your customers so that you know how to kind of keep dithering with models? Because you almost have this water balloon where if you change a model for a particular opinion, it might drift away from another person's opinion. And I realize
Yeah.
you got to thread the needle.
Right, right. I mean, we try to, I mean, our hope is to build more models with variation built in, so the user can ultimately choose which version. So if they're going based on an RTOG convention or an ESTRO guideline, they can pick. We have gotten feedback from clinicians. It's usually um, specific errors with contours with their setup. I mean, if you're doing a 40 CT because our models weren't trained on that, we get a little bit of that feedback where a certain model will not do well, or all of the models won't do well, and they're looking for something that does better on those types of scans for SBRT lung. So we try and incorporate that. Ultimately, you're right. We really do need to just build a separate model to deal with those cases, because if we try and accommodate that type of scan, it will degrade the results on another scan. So yeah, I mean, our approach has been, we try and give variations, and that's kind of moving forward how we see it going to please the different different user types.
Yeah, that's interesting. Now that leaves, I'm kind of a simple-minded slash iconoclast, I think, when it comes to this, because ideally, and this is not what's going on in the world right now, but
Yeah.
ideally there would be groups of experts really driving to consensus on what is kind of right.
Yeah.
And they would be debating and arguing with each other. And I think the consensus studies we're doing have a lot of value there because people can see where the differences are and negotiate in those regions. And then so there would be a standard, and then the vendors would be competing on how well they're meeting those standards, and there is a right answer. The other way, and it probably seems to be evolving now, is you're just going to have a bunch of models that people say this matches what I expect, but it's keeping
Yeah.
the variation out there in the
Right.
universe,
Yep.
which,
Yep.
Dr. Deming wouldn't like that so much, but I think there probably is a phase there where you have to accommodate your different customers and what they want to see. But what's
Yep.
your feeling on what ideally, how would you like to see it kind of progress and evolve in time?
Yeah. I mean, obviously, for us, having one gold standard, it definitely simplifies things. And it makes sense for protocols and dosimetry studies moving forward for everyone to use um, that same metric. Yeah. Right now, I mean that. I guess that on the commercial side, because we have to please so many, we do have to accommodate at this point because that variation is still pretty large. But I do feel like, yeah, if you start using an automated tool, it does kind of move you in that direction because of the ease of use, and if you can make it simpler, then clinics may be more willing to adopt, especially if the community at large is going towards that type of tool. So yeah, I agree. I think that's better. Like I said, the variation of models we see more as if there's different setups and or like if you're using brachytherapy applicators, you really do have to just create a new model or somehow get it such that the model can detect that type of thing before it begins its automated process of contouring. So ideally, we can build that variation in, but yeah, it's something that we obviously think about a lot. Yeah.
Well, that's exciting. We're about to jump into some, we're going to look at some results, and we're going to be looking at it both at the same time, everybody. Oh, and just kind of for the record, and this will go with the other two companies I'll be interviewing. One is confirmed, the other one I'm waiting to schedule. Uh, all the vendors will get the image set 24 hours in advance. None of them said they need that. The original thing was going to be you get it, we do it live. But just in case there's any snags, we don't want that to happen during the podcast. So Kevin got the data, it came back with a structure set almost right away, and that's what we're going to be looking at today. But before we jump into the actual outputs, I mean, if you want to share your screen,
Yep.
give people a little idea of what it would be like in a world of Radformation doing some contouring.
Yeah. So yeah, I'm going to launch from our DICAM interface. So this is really just pointing at a local directory. So this is the case you provided. So we're able to launch either from a structure set or an image series. So AutoContour's segmentation tools, the AI is actually built into the cloud. So what happens behind the scenes is our data set's anonymized. It's sent up to our cloud processors, and you kind of see the status here of each model as it's run through the algorithm. In this main window, you'll start seeing contours return in our topogram view. So it looks like the level 1A is already there. But you can assign different templates. So I feel like one of the standardization benefits of AutoContour is being able to choose different types of templates depending on your protocol, being able to assign different types of models to those templates, assign colors, and then I'll get into a little bit of the review tools that are built in. But you see we're almost entirely there in terms of the contour results.
For those who are a little, because obviously being a founder of Prono, I know that the power of the cloud, and then every once in a while, or maybe more than that, you'll get a little hesitancy about the cloud. Do you have anyone asking for kind of local on-premise algorithms, and do you offer that?
So we do. We're working. We have an on-premise algorithm. Obviously, our primary tool was built with this workflow in mind. But it's definitely a sticking point when it comes to trying to prove that we're sending the scan data and no PHI, and that we're not storing the information. So we're pretty happy with that result, but yeah, getting past the IT piece has been a challenge, and we do plan to release that on-prem version. Really, the drawback is you don't get that instantaneous contour result that you would get here, depending on the hardware that each clinic has available.
Makes sense.
Yeah.
One thing I noticed was when I just opened the structure set that you sent me already, there's a lot of your engine produced a lot of OARs. If you just scroll down, how many OARs did you calculate here?
I would have to count. Yeah, the NUC nodes start taking up a lot, but I will say
30
the
to
other
40,
benefit,
right? I mean,
yeah, 30 to 40, and one of the benefits of the cloud as well is we can do it all at once. So we really we just aim to generate all of our models at the same time. So if you decide I want to add the heart or add the lungs to your data set later on, you have that option. So we have over 90 different models currently available. So this small preview, but yeah, it's obviously the speed is there. That I think previously is what wasn't possible, but it's one of the reasons we really push the cloud experience.
Yeah. So I'm assuming here someone does it require that someone be interacting with this, or does this have kind of an automated mode that'll produce contours without?
So this the cloud-based version, we force the approval process. We're tinkering with a headless mode where we'll generate these automatically for you to import, but we really like the idea of making not just the generation but the review and approval and edit portions really easy. So we actually have the play button to scroll through, to pause, make changes. You have to approve, so you have to review each slice before it can be generated to a structure set. But we try and really speed this up. So this was one of the pain points, at least when I was generating and checking plans, was to be able to go through and make sure every contour is right. It's very easy to just kind of scroll through and not look at everything. But trying to make the review process easier will ultimately, I think, catch more of those errors.
So let me guess. That was for regulatory reasons, because you could always argue that we could produce a structure set and then it's up to you to review it. And I think that would have probably been fine, right?
So it certainly helped. I don't know if it was. It's hard to say what happened in terms of the approval, whether that mattered or not. Ultimately, we felt the contours are doing a pretty good job, but it is always helpful to review them. But yeah, I think including this is something that I mean, really all AI vendors should look at, because it becomes very easy to just assume it's doing a great job when, for the most part, it does. But those few times that it doesn't, you always want that kind of extra check built in.
It's a catch-22. You want people to kind of make sure they spend a little time with it. At the same time, I bet a bunch of your users are going to say, "Hey, I want to skip over this part. We trust your stuff. I want to skip it."
Yeah. Oh yeah. Oh for sure. Yeah. But we think, I mean, if I went through, I mean, I could probably finish up the review process in the next minute, because you automate this. You really just have to work right in this view, and you can speed things up. You can review in different views. So it should really only take you, if the contours are good, should really only take 5 minutes, which is going to save you probably hours for what it would normally take.
No, it's an interesting strategy. This was great, and I'm then assuming you just push this downstream to the TPS or whatever.
Yep, exactly. So you would once you're approved, you would export to DICOM, and then you can bring that into whatever playing system you have.
Well, let's take a look, shall we?
Sure.
Nice. Thanks for that demo. That was super easy to follow. And I have Radformation's data set, the one you saw Kevin just produce. I have it here loaded in the same software we did when we analyzing versus experts AI. And here we can see then that big list of structures that were produced. It's way more than we have the consensus data for. So we'll walk through just the structures we have consensus data for. I'll tell you what, I'll let you pick. I think you know the organs, left and right parotid, left and right submandibular. We got the larynx, we got the constrictor muscles, all levels, and then the brainstem. What do you want to start with?
Uh, yeah, let's start with brainstem. Just start at
Brainstem.
the top. Yeah.
Should be one of the more boring ones, but we'll find out. All right, so let's go find the brainstem. We can kind of zoom in on this a little bit. Um, so we could spend, just for the sake of time, what I'm going to do is just pop open the consensus cloud for this one,
Okay.
and we'll see where it fits in. And then I'll do that same little iteration to see, does it start to look very consistent with the wisdom of the crowd at a specific, or at a, at a certain ISO agreement level. So here we've got the crowd and the Radformation. So
Okay.
you see they're very much on top of each other. In fact, if we look for that green line, it kind of is hiding in that. So uh, what is interesting to see is, where's Radformation come when we get into these regions of disagreement? You are certainly right on this edge there where everyone agreed. You're right on that edge. Even the back edge there, same thing. Seems like
Okay.
you're kind of middle of the opinion, about 50%. The 50% of the people stopped. I should, yeah, 50% of the people kind of stopped contouring where yours did. This looks really right on top of the cloud, which is a good thing. So I'm going to do this little analysis just out of curiosity.
Okay.
And so we find that the Radformation AI at the again, it says it's a dose value. It's a percentage of agreement at about the 32% level with an overlap of 84% or 0.84 dice. So, is there anything in particular around this image, or anything that reminds you of some feedback you've gotten from customers? It definitely looks
I
very
mean,
reasonable.
yeah. The first thing that stands out to me is that high agreement region is actually very similar to what our original brainstem model looked like when we trained it without really cleaning. So kind of taking our clinical partners' data sets and just training a model to see what would happen. And it was interesting that shape, which maybe doesn't have the wing appearance, the wings on the side, and really go down to the top of the dens like you would expect. It was doing this more averaging effect, and it really wasn't until we went through and cleaned the data to be consistent that we started getting this shape, which really we, based on kind of the shape you would, I think, see more if you had an MRI overlaid. So yeah, it's interesting how the averaging of everyone's contours looks very similar to that, that unclean data almost.
Well, when you look
Before
at
training.
the red though, so that's where everyone agreed. I think what we're
Yeah.
finding, or at least what I found with some of the experts, and again, we gotta, just to lay of the land here, the experts didn't agree
Yeah.
completely on everything, and that's the world you have to live in. Um, I could do a direct comparison, quantify yours versus the experts, but I don't think I really want to do that in this context because the experts disagreed. But
Yeah.
what we're
Yeah.
seeing here is a very reasonable result, and more and more, I did see the experts' agreement levels tended to be in the 30 to 45% ISO agreement. In other words, the population, the physicians were drawing more of organs at risk, and that matched a certain less, I guess it's not the 50% agreement, it's less than, which is what
Mhm.
yours is doing. So we could assume and test that that yours is actually matching the experts, at least some of the experts, pretty well.
Yeah.
All right, let's do the other one. Go for it.
Yeah, let's go to parotid then. Yeah.
We will do the left and the right. They probably should have very similar results. So let's
Yep.
go for it.
Yeah, there always seems to be a large amount of debate around the parotid, so I'm curious to see how we did.
There was a high agreement in this one, but in the population. Now this is also an interesting population because it's all radiation oncologists. It
Yeah.
doesn't have dosimetrists and physicists and others in there. Um, Not that that should matter, but it is a okay. You can ignore that. Um, just kind of find, let me go back to what everybody's used to looking at. All right, there's our population. And here we go. All we need to do is turn it on. So it's Parotid L. Oh, yeah.
Mhm.
See, now that is very much hearkening back to the podcast I did a couple days ago where the physicians were in this level. So again, your algorithm, if we were to, let's just say for the sake of example, this means a lot of the population is perhaps under contouring because we saw this phenomenon with the experts as well. Most of them were larger than the area of 100% agreement, and by a lot, and we're seeing that consistent with yours. So if we want to, I don't know if you want to make any, I'll fly from foot to head here, one slice by slice. Oh, you know what's interesting is definitely where you start is where everyone started, so that's a good
Oh yeah,
sign.
yeah, yeah. There's probably a little bit of contrast down there, which I'm assuming everyone can see. It's a little easier down in inferior.
See, I'm very encouraged by this because I think there's a gold mine in getting gold standards from a population of people averaged, and yours is
Yeah.
really matching probably the more conservative views, the larger contouring. So let's see
Yeah.
how our overlap is. Okay, now this is good. Your dice is over 0.9, and
Yeah.
it's at the 40% level.
I will say, yeah, I know that medial region. I know you talked a lot about. I know the expert panel talked a lot about how far to go in. And actually, one of the updates we made to the Parotid a few months ago was specifically to address that wrap around the mandible. We probably had something that was a little less conservative previously, and we essentially updated to try and capture that region, which seems to be moving more in the consensus, and based on the NRG guidelines, seems to include that a little bit more. So we actually made an update to hit that piece particularly. Yeah.
That's great. When you push out updates, here's kind of just a sausage making question. When you push out updates, do you let your users, do you leave the old model there, or does everyone just start getting the new model? Like, do you let them choose when to upgrade? How does that work?
So for Parotid, that was a lot of debate whether to create a separate extended Parotid model, but it was one of those feedbacks where we seemed to be getting it consistently from customers that we were under contouring, and because of that, we ultimately pushed it as our Parotid truths rather than as a separate model. There have been a few instances for cochlea, for instance. We had something more that was the inner ear type contour, and we ultimately pushed a separate cochlea model that was more of the true cochlea. So yeah, in this case, we didn't see it as much as of a large difference that would warrant a separate model, but it's something we certainly debated doing. Yeah.
Yeah, I think it's really worth commenting, and I just in case, like this image could be interpreted in several ways, and I guess it depends on who's looking at it. What we all see factually is that this is where a whole lot of, I think it was about 70 physicians disagreed a lot. So where you see these great, that's a lot of disagreement. Your AI is modeled to go after the more conservative. There is parotid in there, and I do think that's evolving that way because again, if anyone wants to go back and watch the the podcast I did before where we were going through this exercise with the 5 experts, most of them did, not all of them, but most of them did draw in kind of like your model is. So again, this is an area where I think it's a matter of training physicians. And if that's the better way to do it, humans would start doing it more that way, but also a great opportunity for AI to do it for them. And that's kind of the beauty of automation is if it's more accurate, then everyone benefits.
Yeah.
So I bet if we run our little simple analysis, so it's great, even higher dice coefficient, 0.912. Again, right around the 40, this one's a 42.9% agreement line. Meaning if we created a contour from the 42.9% agreement, it would have more than 90% overlap with your AI. I think that should really be comforting to you. It's
Yeah.
comforting for me.
Oh yeah. Yeah.
All
Yeah,
right, how
definitely.
about we stay over on the right side, jump into the, let's see, there we go, submandibular right. Now this one would be interesting because there's a,
Yeah.
yeah. I don't think anyone would hold it against an AI engine if it was a little off here. So let's figure it out. And this is because this was the ipsilateral side. So let me load up. Now, just so everyone kind of remembers here, a lot of disagreement out in the population. So now imagine you're the life of an AI vendor and you're having to please people who naturally disagree. And that's the world you live in, right?
Yep. Yeah. Part of the job. Yeah.
Yeah, but it does seem that the AI does tend to kind of come down in the middle of those opinions, which I guess makes sense. Let's go again from inferior. We'll go slice by slice. People get a quick review. Okay, the purple line then is the Radformation. Big areas of disagreement here.
Yep.
But again, you're kind of in the middle of it. Any comments on this one? I think it's really good to see that you're falling in the middle, but what are your impressions?
Um, yeah, again, this is maybe similar to the Parotid, the superior aspect, where you start to get blending with the oral cavity. So really, it is a little bit of experience. It's a little bit of I mean, if you've maybe seen it on an MRI, you get more of the shape. So I think the AI does something similar, where it's kind of using information from other pieces, not necessarily just the CT values to determine where the edges are, because I think that's probably where most of the disagreement is just where's a border if you can't really see it. And I think the AI is pretty good at making a consistent determination based on other factors rather than just trying to guess at borders here. Because, yeah, I mean, submandibular is something I certainly would have trouble manually doing, and being consistent from slice to slice is a challenge, whereas you kind of see the smooth sagittal view, which is something you may not get when a user is trying to guess on each slice separately. But yeah.
Absolutely. And that your agreement with around the 50, I think it was 54, was again over zero point 0.9 dice. That's a lot of overlap. So to kind of emulate what that would look like as a contour, let me see. It's my software. I have to always remember what I did. What am I doing wrong here? I should learn how to run my own stuff. Close enough. So yours was right in the middle of this band.
Okay. Oh yeah.
And look at that. So this is why I think there's so much potential for these kinds of things. So first of all, that's just look at that yellow line.
Yep.
That's the isodose, I think, at 50 or 60. I mean, if you saw those as two human contours, you would say those are essentially equivalent. Okay, I'm kind of excited about this result. Let's do the other side. The other side actually should be
Yep.
a lot easier, right?
Yeah. Yeah, I think so.
All right. And this was one of the more consistent contours. The right
Yeah.
submandibular had a lot more variation than this one. And here's the cyan line is so above the edge that you can't even hardly see it.
Yeah.
Another good sign.
Yeah, I think the little improved contrast on this side, so maybe more clear borders that everyone was able to agree on.
But again, you're having this opinion that goes up superiorly, kind of like 50% of the population. So let's do that same 0.914 at 50%. So the other side was at 54%. So this is definitely in the ballpark. And again, just so people can see how similar the AI here is to the consensus, I'll be a little smarter this time. I'll leave the whole thing on and just kind of trim it up to 50%.
Yeah.
See, you should tell me, be a backseat driver because you're probably doing. Well, look at that. So just pay attention to anything that's colored versus the cyan. Dude, that is very
Yeah.
nice. These are reconstructed sagittals, so they're a little bit ugly with my software. So let's go through. Very promising.
Yeah.
Nice work.
Yeah.
All right, now we're getting into a little bit scary. So scary, not
Sure,
that
yeah.
you should be scared, but scared that our industry really has some work to do. And let's do the larynx. And I think the issue with the larynx is there was huge variation with our population of physicians. And I don't know if that's because it wasn't spelled out in enough detail which particular protocol to follow, but they did give instructions. So
okay. Yeah, you didn't throw a big curveball. Thankfully, you could have given us something with a ton of artifact, or some customers like to do that. Send us the poorest scan they have with the strangest anatomy and see how it does.
It's important to study outliers.
Yeah, yep.
But I think when people are adopting AI, they should very rigidly say this is where for even these are the structures we need very little review or editing on at all. And then in the same model, there may be some where they need more review and some manual editing. And that's really on the end user to figure out that process.
Yep. Yep.
Okay, so what we have here is, let's go. I think it's actually, even though it's an uglier picture. So you see there's a lot of variation with our physicians here.
Mm-hmm.
You are definitely overlapping that. But we start to see a difference. I think if we find a max agreement line here, the dice may be a good bit lower. So 0.802, that's still 80% overlap with the 45% consensus. So where do you see some structures or anything here that rings a bell?
Yeah,
particularly up here.
I mean, yeah, I think the biggest difference is that that supraglottis region, and I think our model, this is where larynx, I think the specific definition becomes important of what you're contouring, because I think our model is more of a traditional protocol definition where you're just going from the hyoid down to the cricoid cartilage, so it's a consistent shape throughout. You're not really contouring that subvolume, which is something that we've kind of left in because we haven't gotten too much feedback of it not being helpful. So I think a few customers have asked that we do that epiglottis, the glottic larynx, so more of a subvolume for certain protocol constraints. But one of the things with AI is it's a very simple structure. It has very clear defined sup and inf borders. So that's kind of ultimately what we went with. It's probably one of those things trying to please the most people. So if you get too specific with a contour, it may not work for everybody, but we feel like this is a good starting point.
For sure, especially when the differences tend to be where you stop inferior or superiorly, because people can just add on more slices.
Right.
So if the slices you do produce, they're happy with largely, then you've still saved a lot of time. They'll just need to go in and say, well, add that other region or something.
Yeah. And it's definitely something on our roadmap to include the supraglottic and the glottic as separate models, but probably one where we would keep this definition because a few of the protocols actually call for that type of shape and contour. So, yeah.
Very good. Well, I think we only have one left, and it's the doozy. Huge variation here, but also because it's kind of a narrow, surfacey structure, this muscle.
Right.
Now, first thing I was impressed with was you produced it. I don't know enough about all the different solutions out there to know whose head neck models are producing the pharyngeal constrictors. So, but yours does. So I was pretty pumped we get to look at it. And here we go. You call it
muscle MUSC muscle constrictor. Based on the TG 263 definition.
All right.
Yeah.
Let's see. We can kind of look at a bunch of different views. Let's take kind of a high level view. Sagittal. Let me shrink it down. So you're overlapping the color. That's good.
Yeah, yeah.
You're a nice contiguous. So the fact that there's not a lot of red here means that there was a lot of non-overlap, but people are kind of in the same area. Again, a lot of disagreement amongst the physicians about where to start and where to end. You went way down. Your algorithm goes way down to the bottom and starts when we first start seeing contours at all. That's interesting. So Radformation definitely is starting at the most inferior portion, agreeing with or kind of the limit we saw in our physicians.
Yeah.
These are beautiful pictures. If you go back, I don't know if you had a chance to watch or anyone who's watching this one, go back and watch the experts. And when I pop the different experts on here, there wasn't a lot of overlap there. So kind of the general shapes were the same. But here is, everyone's in the right area, but the flatter you get or the skinnier you get, the overlap obviously goes down. But we see a good, you're encompassing. Man, it looks pretty good. I got to tell you. Look at that.
Yeah. Yeah, so this is one of our newer models. It was something that we really kind of started from scratch because it seems to be, at least for me, I wasn't contouring it when I was in treatment planning, and so we really used that NRG guidelines for definitions and tried to produce the most consistent result.
Considering how skinny this is and that we're just looking at overlap, a 0.731. Now here, this is interesting too. You're matching with a much lower consensus, meaning you're being more, you're finding more than the average physician, but your overlap is very good with that 20%. I believe when I looked at some of the experts, some of these dice were down in the 0.3s and 0.4s. So of overlap with the population of their peers. So again, we're not really saying what's right and wrong, but my gut reaction is this is extremely reasonable and promising, and I think your crew should be pretty happy with this.
Yeah.
Awesome. Well,
yeah, it's really great to see. Yeah, obviously we, really like to see feedback, and this is a rare opportunity to see it against
sure.
a lot of different users. Yeah.
Well, if there's any usefulness for these grids, these are basically just RT dose files that are, 100% means everyone agreed. So you could load it and use it. If you have any reason to need them, I'm more than anyone who kind of opts into these podcasts, you should at least get that from us.
Yeah.
So let me go back. Let me switch back to the camera real quick. So Kevin, I think you should be pretty stoked about those results. I am. If you can drive out variation and it starts to look like we're a consensus of physicians agree, I think you're doing great things. So I want to close it up with a little kind of maybe help your users and future users, all the physicists, dosimetrists, and physicians out there who are without a doubt going to be adopting AutoSeg. If they haven't already, they're going to be doing it on turbocharged for the next year or two. In your ideal world, how would that customer kind of test your wares and communicate with you about the results?
Yeah, it's a good question. I mean, ideally, it's just finding 10 probably just random cases from each specific region, so head, neck, thorax, pelvis, and really just running AutoContour and lining them up, putting an overlay just like you're doing, and really just evaluating. Would you accept that contour if you were going to approve that plan? And I guess deliver treatment, and with everything involved with delivering dose, with the uncertainties of setup and all that, would those models be something you would approve and check off on? I mean, obviously, getting some automated metrics overall. If you're going to compare between vendors, you would want to maybe a quantitative value there, but ultimately it's how does it work with your workflow? Does it save you time in the long run? So getting that trial and actually using it day to day, does it get you your final result the most efficient way.
Yeah, is it better than what you're doing now? I guess it's
Yeah.
general.
Yeah.
One more question, and then you're off the hook, and you can plead the fifth on this one.
Okay.
Let's say you've got just this is hypothetical. It's one main rad onc, a small clinic, or one person is kind of dominating. We're checking out the autosec, and they do exactly what you just said. And your results in some organs or a few organs disagree a lot, but you look at it and based on everything you've seen from other people, you think they're the outlier.
Yeah.
Do you like it's a tough spot for you to be in? You don't want to tell a physician that they may not be agreeing. How do you handle that?
Yeah. I mean, really, I think that's why giving the trial and not, I guess, not pushing too much on it, really letting them decide. Yeah, we certainly appreciate like that feedback because if we do start hearing it from a lot of clinics, we will ultimately uh, push to change the model like we did for the parotid or for cochlea. But yeah, ultimately, yeah, the customer is always right when you're trying to sell. So it's really if it doesn't work for them, it's I guess more on them. We're not gonna we can't force them to use it, obviously. So yeah, it's something that we definitely take into account as we make updates and consider what's going to come next for models. But yeah, really,
Diplomatic. You have to be diplomatic.
yeah,
Because
yeah, exactly.
and you don't you the customer's always right. I like how you said when you come into sales because there doesn't mean they're right if they, if 10 different physicians who draw 10 different contours can't all be right. It's an interesting situation, but I just realized maybe these consensus studies, both with C3RO and anybody else who wants to do these, autoseg vendors could have this in their back pocket and say, okay, yeah, we don't overlap a lot with your opinion, but there are a lot of other opinions out there, and here we have 100 of your peers, and it shows that some of them. So on average, we're agreeing with the most possible. That may be a further. It's diplomatic, but it's also kind of opens their eyes to,
Yeah,
oh wow, so not everyone's doing this the same, and that would make the world a better place too, I think.
yeah. No, yeah, I agree. I think that might be the most powerful is showing that consensus data because otherwise it might have just been the way they've been contouring it for 20 years and never really considered changing. But it is difficult when their experience is based on that style of doing things. Yeah, you do have to consider maybe not changing like the larynx if the larynx side effect data is based on that type of contour. Do you want to push people to change to a smaller substructure when maybe the data doesn't support it? So
Well, you raise a
the
you raise a really good
yeah
point. As we hopefully start to harmonize in producing contours, if those are different contours that have been kind of used typically by people in clinical trials,
yeah
we should go back and look at the objectives and metrics we're studying.
mhm,
I would love it if all clinical trials, I mean, this is another ideal world thing, start to use some kind of AI engine to reproduce all the contours just to give some kind of consistency.
yeah
But I think the ultimate way to validate AI is, do these contours produce DVH values that are more predictive of outcome? And then you've really proven that's a better contour, even if you don't like what's on the screen, if it's more predictive. That's
yeah
what a
yeah.
scientist would answer. Hey, Kevin, this was awesome, man. Are there any parting words? We're kind of running out of time. Are there any parting words you'd like to tell people? Otherwise, I thank you a lot.
Um, yeah, I mean, not much. I mean, obviously check out AutoContour. Yeah, reach out to our team. We're always happy to set up the trial and get you started. And if you have any ideas for new contours, we're open to building that. We have a really good team of experts to generate those contours quickly, and we're always putting out new models. So yeah,
Well,
yeah, reach out.
thanks for volunteering. Your stuff looked really nice. Everybody, it's Radformation. I'm sure everyone's heard of them in our industry, RAD Formation. This is Kevin, and this was Contouring. So until next time, see ya.